Okay, hello everyone. My name is Kirk Watson. For this project, I made an Ethereum wallet operator. So this application allows a user to connect to the Ethereum network and use their Ethereum wallet. Some key features include the user can view their Ethereum balance of their own wallet, or they can also view the Ethereum balance of any wallet on the blockchain. Another key feature is that the user is able to send Ethereum to other wallets on the Ethereum network. This application is useful for anyone that wants to view the balance of Ethereum wallets or wants to send Ethereum to other users on the blockchain. So to implement this project, I used Python and their Web3 libraries. I used the Ethereum network, and I used Ganache, which is a developer blockchain for Ethereum that allows developers to test Ethereum functionalities without risking their own money or security. So for the first architecture style, I chose client server. In the client server model, there are two main components, the user client and the server. So in this example, in this project, the user client interacts with the user and is able to get user input and their private key from the input file. The user client also is able to display Ethereum balances and transactions to the user based on their requests. Server in this model is the Ethereum blockchain. The Ethereum blockchain is made up of many Ethereum nodes that are on a peer-to-peer network, which are basically connected state machines. And this allows the user to access and write data on the network. And to connect the user client with the server, you use a procedure call, which in this case is a JSON RPC, which can be a Ethereum local node, or it can be a URL given from a provider. The class diagram for this model is made up of three components. It's the interface, which is what interacts with the user. It allows the user to give input, and it has the main functions of viewing Ethereum balance and sending Ethereum. The Web3 class is what connects the application to the blockchain. What it does is it uses the RPC to connect to the Ethereum network and then authenticates the private key, allowing the user to operate with their wallet. The parser class is what reads the config.json file, which has the user's RPC URL and their user's private key. And with that information, they can connect to the Ethereum network, which allows the interface to send Ethereum or view wallet balances. So mapping the components to the implementing classes. So the interface with the launch and menu functions, it allows the application to get user input and display balances and transactions. The view balance and send Ethereum is what allows the application to write and access data on the Ethereum blockchain. The Web3 class has the authenticate key function and connects to the blockchain function, which is a procedure call using the Web3 interface and RPC URL to connect to the Ethereum network. The parser class is what gets the user input from the config.json file. So for the second architecture option, I use the pipe and filter model. So for the component diagram, it's pretty linear. It starts with reading that config.json file and getting the wallet private key and the RPC URL. And with this data, the application is able to connect to the Ethereum network and authenticate the wallet. With this data, the application is able to get the user's input, which leads to the user entering their Ethereum transaction input, which is like how much Ethereum do they want to send, what address they want to send to, and how much gas do they want to use. With this data, they're able to send the Ethereum transaction to the Ethereum blockchain using the RPC URL. And then with the data from sending that transaction, the application will receive a transaction hash, which allows the user to see the status of that transaction. After that, the menu gets user input from the user, which allows the user or the application to use the data to display the Ethereum balance. So the class diagram, you have the parser, which reads the config.json file, the Web3 class, which connects to the blockchain and authenticates the wallet. Then you have the menu, which gets the user input. And then you have the send transaction class, which uses the wallet authentication and the user input to sign and send a transaction. With this, the transaction hash class is able to display the hash to the user. And then the menu is able to get the user input, which will lead to the user requesting to get the balance of their own wallet or another wallet address. So mapping, the parser gets the wallet's private key and RPC URL from the config.json file. The Web3 class connects to the Ethereum wallet, Ethereum network, and authenticates the wallet. The menu gets the user input. The send transaction class gets the Ethereum transaction input and sends the transaction using RPC, using the RPC URL, which leads to the transaction hash class, which displays the hash. Then you get the user input again from the menu, and then you display the Ethereum balance. So pros and cons between the client server model and the pipe and filter model. The pros with client server is that it encapsulates the entire architecture of the blockchain and its connections. And what I mean by that is it shows the entire blockchain and and how they interact together. Another pro of the client server model is that most data is on the Ethereum network, which allows the application to be light and deployed on many machines. One con of the client server model is that you face the risk of single point of failure, which means if one part of the application doesn't work, then the rest of the functionality of the application won't work. And so some pros of the pipe and filter model is that it portrays data flow from the wallet authentication to getting the transaction hash, and it supports easily serializable data structures used in this application, which means this application, the data flow in this application is very simple, easy to follow. Some cons with the pipe and filter model is that it doesn't support interaction between components because it's just a linear flow, and it doesn't encapsulate the connections to the blockchain like the client and server model does. So with this information, I decided to use the client and server model. I chose the client and server model because the architectural style illustrates the full flow of how the application interacts with the Ethereum blockchain. The application can be deployed onto multiple machines and can connect to the network using RPC providers or local Ethereum nodes. And then most of the data used in this application is already located on the Ethereum network, which means the application is very light on the machine. And so now we'll get into the demo of the application. So for this project, we're going to do a demo on the Ganache simulator blockchain. I'm doing this because this will keep my information secure while also not costing any money. So this application works just fine on the Ethereum blockchain. All you got to do is get an actual RPC URL from a provider such as Alchemy or Infura. But so to run the application on Ganache, all you got to do is quick start an Ethereum simulator network. So once it loads up, we can get the RPC URL. Which is right here. So we want to copy this. And then we want to go over to the project directory and open the config.json file. Oops. And then we want to copy and paste the RPC URL. And to gain control of one of the wallets, see here's all these wallet addresses right here. This first one we can claim as our own wallet. So what we'll do over here is grab the private key and copy it. And then we want to paste that in the config.json file. And then we want to save it. And now, just like that, we're ready to go. So let's keep this over here. And we start the application. So when the application starts, it's going to connect to the blockchain using the RPC. And then it's going to connect to the wallet using the private key. And as shown here, it has successfully connected. So next we have two menu options. We can either view Ethereum balance or send Ethereum. So for this, I guess we'll start with viewing a balance. So we can either view our own balance or view the balance of another wallet. We'll start with our own balance. You just click one, and just like that, you have 100 Ethereum, as shown here, 100 Ethereum. And now we can return to the menu, and let's send Ethereum. So, okay, let's send some Ethereum to this address. So we want to input the address, how much Ethereum we want to send. Let's just send 10. And then how much Gwei would you like to use? Gwei is basically gas. So gas on the Ethereum blockchain is kind of like a tax that goes to miners that process your transaction. The more Gwei you use, the higher priority your transaction will be. For this example on the Ganache simulator, we don't really need that. But if you were using this application on the actual blockchain, you would obviously want to put a reasonable gas price. But so we can just put 50 here. And then just like that, it sends the transaction of 10 Ethereum. And as shown over here, my wallet now has 90 when it was 100. And the second wallet now has 110 when it originally had 100. And the application also provides the transaction hash, so the user can check the status of the application. So over here, you can search the transaction hash, and just like that, you can see how much Ethereum was sent, who sent it, and who received it. So to view the transaction hash on the actual Ethereum blockchain, you would go to websites such as Etherscan and just search the hash the same way. So now we can go over to view Ethereum balance again, and we can view our own balance again. And now it says 90 Ethereum. And then we could also do it again. And we can view another wallet. Let's just view the one we just sent to. And we input that address, and then we can see that it has 110 Ethereum. And that is basically it. Thank you for listening, and I hope you all enjoyed this demo.